I'll introduce myself. My name's Richard Hailstone, and I've spent the last 3 years at Red Hat as a solutions architect. Prior to Red Hat, I have 20+ years experience in IT, working across verticals such as telco, finance, development, and service providers. And through all those roles, I've performed a number of functions, mostly Unix and Linux administration, network admin, firewall admin, SAN admin, generalist, which most of us are these days. And I've also had the privilege of holding some architecture roles in the infrastructure and enterprise space. More recently, I also spent 3 years building security products for federal government and held the role of a security architect. So hopefully that comes out in what I'm talking about today, which is automating security and compliance in the world of containers and hybrid infrastructure or environments. And I'm going to be going through cloud scale, doing that at cloud scale, because that's kind of the buzzword of the moment, and everyone's using cloud in one way or another. Then I'll go through containers and our security kind of principles and ways to operate in the container namespace. And then we'll delve into security teams or secure operations teams and infrastructure teams and what our sort of product offerings and things are around there. So it's pretty easy to understand depending on your ability, sort of hallway conversation level. Maybe we'll dive a bit deeper in certain slides. But I've got about 30 odd to get through, so I better get a wriggle on. So Red Hat, I think when most of you think of security vendors, Red Hat's probably not the first vendor that comes to mind, right? You don't think I'm going to go buy a perimeter edge security device from Red Hat. Okay, yet you think more like I'm going to go and talk to FortiGate or one of the more traditional security vendors. Okay, but the adoption of cloud scale infrastructure means that the landscape for security is rapidly changing. Okay, so there's massive variety and veracity in exploits, and this fast-paced, vulnerabilities and exploits that are being developed really puts us behind in combating the problem as a whole. Okay, but our philosophy is that we really need to focus on combating the problem by fixing the easy things first. Okay, yet more than 60% of hacking breaches are using weak passwords or stolen or weak passwords or using default settings to exploit systems. And this is costing business and customers lots of money, in the order of $3.86 million per breach as surveyed. That's a hell of a lot of cash. And that number, if these are basically known exploits, then we've got remediation available to address that. If it's known to us, then we can fix it before it becomes an exploit. So this is something that we can fix easily. And Red Hat provides tooling to do that. So we've got scanning, automation, compliance tools that can detect weak passwords and enforce the setting of complex passwords and complex rotations straight out of the box. So we believe that fixing this problem of known vulnerabilities is pretty simple, or fairly simple. Yet, the challenge is not getting any easier for most customers. In fact, when surveyed or when asked, most of them were saying that the severity of attacks was getting increasingly harder to diagnose and follow up on. So 65% agreed to that premise. And as part of that, they said that the attacks were getting more sophisticated. And as a result of that, the attacks were taking longer to resolve. So the time spent on resolving these incidents and exploits is increasing. And because of that, customers are only actually visiting or triaging up to 5% of incidents identified. So there's 95% that we know happened, yet we don't have the time to go and investigate them. And that's quite a problem. So if 95% of them are known exploits, then we can easily remediate or address those using automation in one way or another. So the sophistication of hackers and cyber criminals continues to increase because of cloud scale. And so how do we combat the problem at cloud scale? All right, so we believe the problem is it's not people, it's in fact the approach to security that people often take in the enterprise. And I'm talking about manual procedures for triaging events or security operations, people following run books and things like that to triage events and follow up on And ultimately, manual procedures and processes result in things being missed. Okay, people go to lunch and they come back and they start at step 3 or step 4 instead of step 2, okay, and miss things. And manually triaging and following run books takes a lot of time as well. So really, at cloud scale, there's no choice but to automate these things. And just like this Amazon warehouse has been able to automate the process of handling millions of packages, right? They're automating there. In the form of these robots, taking orders and visiting these robots up here, taking orders and fulfilling the order. So taking the packages off the shelves, bringing it back, sticking it in a box, and then off it goes to the customer without any human interaction. And so when I look at this picture, I think that there is a lot of automation going on in this image. There's a lot of automation. There's no humans in there. But there's also got to be a hell of a lot of compliance going on behind the scenes as well, a lot of security going on behind the scenes to mitigate against people entering the floor, for example. You know, you don't want people getting run over by these robots. Or what happens if one of them loses power or his battery goes flat? You know, and it blocks the pathway for the rest of them. So there's cameras and processes and things monitoring all this, and no doubt when things are triggered, and I've actually seen some of the image recognition capability that Amazon has to do this, but you know, no doubt there's automated events and processes and procedures that happen based on those cameras seeing things or packages falling on the floor, and the whole system turns off, right? So basically, the rapid deployment of infrastructure means that we need a more automated approach to security. So enough about these Kiva robots at Amazon. Let's move on. So the point there is that perpetrators are using automation for cyber attacks. Okay, so what do I mean by that? This is a screenshot of an instance that I put. It's a publicly addressable instance that I built in the cloud. And as soon as the SSH process came up on this box, there was automated these IP addresses coming from Japan, China, Europe, because I looked them up, and they belong to service providers in those countries, right? Those IP ranges belong to service providers in those countries. And as soon as this system came up, it was trying to exploit this camera user, which you might remember, this admin user that used to exist by default on Linux, right? Doesn't in RHEL, but you know, it still does in some distros, and no doubt some of these accounts have default passwords set. So there's automated tools out there looking for new systems popping up on the cloud and automatically trying to attack them. And when they get access to the shell or access to the system, they're loading software that allows people to command and control or do stuff with them that we don't want them doing, right? We don't want people that aren't authorized accessing systems. So the bad guys are using automation, so we must fight fire with fire, and we think that the defense strategy of the enterprise must also be automated to deal with the perpetrators who are automating. Okay, otherwise, if we don't, we'll fall behind. And by that I mean sort of fall behind in the sense that, in terms of like an analogy, if I was part of a team, like a football team, and my whole team was training and improving and getting fitter and faster, and I wasn't, I'll fall behind. And if the other teams that we're playing are doing the same thing, then they'll improve and progress, but I won't. And I'll gradually fall behind because I won't be able to keep up. I never took the initiative to stay at the forefront of the problem, so to speak. Okay, so we must automate. And these perpetrators are using artificial intelligence and machine learning, and all sorts of sophisticated measures to go and grab more meaningful information from social media sites and the like to form a more rounded view for things like phishing emails or more targeted attacks and more sort of persona-driven info to deliver to you, to get you to click on that link or to get you to do something that you wouldn't normally do. So it must be automated. And in order to automate security at scale, Red Hat believes that you must use a continuous and holistic approach, right? So we're not talking about manual procedures, we're talking about an automated approach to it and integrating security throughout your whole life cycle. And we're talking about security being at the forefront. That one turned off, okay? Being baked in at the start. So when you build a system, for example, up here, As soon as you build a system like the one I built, you need to harden it, you need to secure it, you need to turn off all that default stuff and put a compliance profile in place. You then need to run it that way for the lifetime of that VM. Security should be turned on by default, not an afterthought. We then use these other events or other points in the process to adapt and implement new fixes or new controls in our infrastructure as code that we're using to harden these systems and enforce compliance. And we can use, when we're using infrastructure as code to enforce security processes and policies, it does mean that at any step in this sort of IT lifecycle, we can adapt and change and update and get in front of those perpetrators that are trying to attack us. And we can use an automated approach to addressing all that. Because security isn't a static thing. It's not a, like, do it once and then we're done, right? We need to adapt so that the next VM that comes along gets the latest sets of controls applied and the latest exploits are mitigated on that particular build, right? And then we need a way to then replay that across the hosts that already exist. So this kind of holistic view, describes what we believe using automated approaches to security and coordinating security requirements into every part of the life cycle. And so it's only possible to achieve this holistic view if security is baked into the development and operations, i.e. the build and run, okay? And only if IT infrastructure and security are implemented as code, so they become repeatable, shareable, and verifiable. Shareable being the key one, right? Greater visibility about what the controls and compliance is on our infrastructure, using version control, for example. And we can only do this holistically and continuously if we continually monitor and have automated controls and remediations to be able to adapt and rebake and redo. So let's review how the automated approach can be achieved for applications, security operations, and infrastructure in the world of hybrid cloud and containers. And I'll first talk about how that's done let's dig a bit deeper into applications and how customers are deploying applications at cloud scale and both on their own infrastructure and the data center infrastructure and public cloud. Okay, and they're doing this on containers. Container platforms are quickly becoming the norm for customers to deploy things like microservice architectures, or in the banking area, smartphone applications for tier 1 customer-facing applications. And they're doing this through containers. Perimeter security in a container world is still very important for things like securing the authentication layer and the load balancing layer and all those things. But I believe, or we believe, that security is shifting a little bit from being perimeter-based to a little bit more around content-based security and how we operate. And what I'm referring to there is more like a zero trust kind of methodology to security, where we still have perimeter security in place around the edges of our networks and our clouds, but zero trust is about not trusting your neighbor or the container that's running on the same host or the same kernel, okay? Or even in an OpenStack platform, and one tenant being completely separated from another. So think zero trust methodology and how you actually achieve that. So let's first explore the various aspects of security running applications on OpenShift. And that all starts, obviously, with Linux security. So Red Hat has a long history of securing Red Hat Enterprise Linux and the Linux operating system. Okay, and this is the Linux operating system is the consistent foundation for all our platforms, and it all starts there. And I know that doesn't sound terribly exciting, but if you think about how containers are nothing more than a process running on the Linux kernel or on a Linux host, then therefore all our strengths in securing Red Hat Enterprise Linux extend to containers naturally. Okay, so I'm talking about things like control groups here, which do the resource limiting, how much CPU and execution time, how much scheduling time a process or a container gets within the kernel, how much memory it can access. We've got things like SE Linux, security enhanced Linux, which is a way of providing access controls around all the resources and things on a Linux system. And implementing things like whitelisting and blacklisting between container pods, and what libraries they're allowed to use and and implementing that zero trust methodology. And of course, kernel namespaces, which is another crucial part for context separation within the container workloads. And so, referring back to Linux and our long history in securing that platform, I'll refer to the common criteria, right? Many of you may or may not have heard of common criteria, but it's a stringent international security standard and a level of assuredness that a product will actually supply a security profile as stated. And the Common Criteria Foundation will go ahead and certify that for vendors. And that's part of the long, arduous task we go through on behalf of customers so they can run a Common Criteria certified operating system for regulated environments like telco or federal government. And we also have the FIPS compliance or the cryptography standards. So our cryptography algorithms and things like that we use in the OpenShift API or across the master nodes, we can turn a FIPS enabled setting on within the operating system to achieve a federal information processing standard, these are like basic tickets to the dance in the US, okay? And they do apply here because our defense also uses some of those methodologies. So, RHEL has achieved this for every version of Red Hat Enterprise Linux. And the container platform itself, our OpenShift container platform, has been built to host Enterprise Linux around this secure foundation. Right? The platform simplifies running containers at scale for our customers by offering the comprehensive suite of capabilities and tools that are supported out of the box by Red Hat. And the alternative to this is cobbling together maybe some open source projects on your own, or maybe going to market and using maybe a less mature market offering. By less mature, I mean maybe the Linux platform at the base of it, and all those certifications and secure foundations that we use. This is a multi-tenant platform. It adds all the several components to Kubernetes to secure it as a multi-tenant platform. We've rewritten the TLS in RHEL 8 so that it's all FIPS compliant. So all the X509-based certificate and role-based access control and token-based authentication is inherent using those compliant crypto algorithms and things. We can enforce through the platform project quotas, so that if a perpetrator does get access to the platform, what they can do and what they can consume on the platform doesn't affect anyone else there. Okay? There's also things like the etc.d process, which maintains the cluster state that isn't directly exposed to the master nodes or the containers themselves. So we've pre-thought all this stuff through and provide it to customers. Another way in which we secure or make hosting applications on containers more secure for customers, is our certified container image repository. So this is just another way that Red Hat helps customers operate container workloads or operate applications securely. And you can look at this at the same way at which we supply secure content for Red Hat Linux, how we curate and supply security fixes and update errata and patch vulnerable libraries and things. We do the same thing from the container image registry so that customers don't have to go and use public repositories like Docker Hub that aren't always vetted and aren't always tested. And there's examples out there where some of the images in these public repositories are tainted and have found crypto mining, source code and things like that has been downloaded millions of times, and people must have run these in the enterprise or in one way or another. So mission critical applications is it's not the trusted and supported way that we recommend of running without this. We also supply a thing like this health index here, so that you can be assured that these container images are running the latest security fixes, patch sets, where A being really good, whereas F further down the scale may mean this thing's like 365 days behind. And our OpenShift platform takes note of that and may or may not halt the deployment of a pod based on some of these parameters and things. Okay, so and if a customer's creating images from scratch, we also have, if they want to bake their own images or use the source to image function within OpenShift, we provide, or they're downloading, or they persist in downloading public images and using those to deploy to OpenShift. We also have this Red Hat Quay container registry. This can be used, and this supplies real-time declare functionality within this platform will scan images upon upload and alert developers of any vulnerabilities or any library issues within those container images. And this works for both applications and containers alike, and can be run on its own or in conjunction with OpenShift. It offers a couple of other features such as geo-replication of the images and tagging, so that we can use the tagging to roll back to a known good image at any time. And OpenShift also comes ready with tooling, right, to support continuous integration, like CI/CD pipelines. And the tooling and the functionality within OpenShift allows you, as a customer, the integration that you need to introduce multi-vendor security tools, like I heard mentioned earlier, like Twistlock and Sonatype, for further security measures and further analysis and things like that within your container platform. So in your pipeline, you can build it the way you want it and alert developers the way you want them to be alerted, and triage events and things like that the way you're already using it. And you should, And so now, let's explore how Red Hat Ansible can be used to orchestrate security operations. Okay, and so security operations teams are centralized units where many organizations, traffic and logs and things might pass through. And there's operators and things like that functioning in these teams, watching logs, and using security products, and protecting environments. But let's take a look at a typical day in the life of a security operator. Okay, and this is pretty much what they're tasked with. The vast world of cybersecurity tools, what I was talking about earlier. And there's advanced threat protection up the top here. Probably this one's better. Network and infrastructure security, so firewalling. We've got web security appliances, SIEMs, IPS and IDS, identity management access platforms. All these solutions need to be interacted with based on triaging events. There's also the next-gen, I think we mentioned earlier, like next-gen cloud security operators and tools, that are coming to market to address customers' more modern needs in those sort of layered environments that I was talking about earlier. So customers are using like a combination of all these products, and we see a problem with this that we can solve with Ansible, okay? To relieve SOC teams of having to cobble all those processes and practices together. So we've designed an Ansible security automation offering, and it's designed to automate responses to threats across security domains, so across multiple tooling. And Ansible's, our vision is Ansible is the standard language across security automation as a language, integrating and orchestrating all these different tools together. So we're partnering, as part of this, we're partnering with specific vendors who are market leaders in their respective domains. And we'll be covering specific security silos like security event management, or SIEM, which is just basically a big log collection influx point within your environment, or with enterprise firewall vendors, IDS and IPS vendors, and privileged access management too, with CyberArk, who's actually out on one of the showcase solution stands out the front here. And since security automation is a broad topic, we're targeting 3 specific use cases with the automation, which is triaging of suspicious activities. Okay, so this is basically log grepping and source logs and detecting anomalies within your environment. We're also looking at threat hunting. So this means that when things are detected within the environment, blacklists and malware lists, and notifications and things need to be updated. So we can automatically detect, check some files and things like that, and then update some of the ecosystem around us. And finally, as a result of some of those, we might want to have an incident response to it, like actually updating a firewall policy to block traffic. So we believe through automating some of these use cases, we can actually improve the security posture and stop some of the malicious events that are going missed. Okay, so lastly, let's explore how the Red Hat tooling, like Red Hat Insights and Ansible automation, can help block potential threats across Red Hat infrastructure. And the objective through this next couple of slides is to talk to how infrastructure is operated securely and some of the tooling and platforms and things that we have around that. And there are various tasks involved in securing IT infrastructure. Okay, so the IT operations teams and groups will do things like vulnerability and compliance scanning, and then they'll do hardening based off that. You remember the holistic circle that I mentioned earlier? So they'll be living these sort of processes and practices, but then they'll need to enforce an ongoing automated compliance state, and hopefully they're doing automated patching of hosts. So sort of to bring this together, a customer may deploy a VM, they may install something like an insights agent as a post-build task on that VM, and that will allow them to, for the duration or the IT lifecycle of that VM, ensure an ongoing automated compliance profile and fix, known exploits and instigate automated patching of hosts. So automation and analytics are the key in this space to an effective security and compliance posture. And I don't know if you know, but so all this capability is conveniently available to customers through our SaaS portal, cloud.redhat.com. Okay, so we're now bundling in, at part of Summit 2019, it was announced that you buy Red Hat Enterprise Linux, and we're now giving you Red Hat Insights as part of that product set. And some of the recent Real 8 announcements that was announced as well. So this is applicable to RHEL 6.10 and above. And for those that don't know what Red Hat Insights does, it's it proactively identifies risks and vulnerabilities and configuration problems across a customer's environments and provides tailored automated remediation steps to mitigate those risks and config problems. It's the only piece of software where you can take a combination of x86 hardware and a specific RAID controller, the firmware and a kernel version, and proactively tell customers that there's a problem with that. The only way we do this is because we've provided Red Hat Enterprise Linux support to customers for the last 20-odd years. And 86% of the support cases that customers log are about pre-known conditions or problems. Okay, so we've taken all that knowledge and the resolution to all those problems, and we've now, with a customer using the Insights client to upload snapshot details about systems, we can now process that information and match the information that they provide against configuration, security issues, and other vulnerabilities, up to 50 critical security vulnerabilities. Now, this isn't designed to replace satellite or smart management in any way, but it's just designed to proactively tell customers that things could go and will go wrong. And we then, provide Ansible remediation for some of these configuration problems. So here's an example where 18 systems here, we've identified an issue with a package, and there's a security automation remediation in the form of an Ansible playbook to play out across those systems in the form of an Insights plan. So this tool ultimately increases the security, the stability, and the availability and performance of your IT operations and infrastructure. And I mentioned Ansible a few times, and that ultimately brings me to Ansible as a technology, and we discussed it briefly in the security automation offering in some of the previous sections. But this is the Forrester published this wave recently and put Ansible and Red Hat in the leading quadrant just because of the praise that customers are giving us based on this technology and what customers can do with it as a holistic infrastructure automation solution. And the cool thing about Ansible is that it's not, it's operating system agnostic. It works across Windows, it works across networking, Linux, cloud, you name it. So therefore, a compliance profile and infrastructure as code is then possible across all those different pieces of equipment as well. And it's the 7th most contributed open source project in the world. Red Hat now has 4 million plus systems under subscription, under an automation subscription. The customers are using that. And we mainly attest that to the technology itself because it's simple to use. It's very simple to use. It's very powerful with what you can do with it day one. So customers are writing simple automations day one, and day two they're playing this stuff out across infrastructure and remediating stuff automatically. And the third one, which is possibly the most important, is that it's agentless. There's no software lifecycle involved in running Ansible on the endpoints. So that's a really major feature there. So it's agentless. Okay, so I'm almost out of time. So I just wanted to quickly mention that in terms of what I've spoken about across all our platforms, security is always a theme, and we offer training and certification in that space across all our product portfolio, included with certification and an exam. And the learning subscription, which improves adoption and long-term value out of using Red Hat products because your staff and yourselves are better trained and more well-versed in what works well using Red Hat software together. Now, this is access to over 60+ online courses. You can learn them any way you want. And we're ongoing and updating this every second of the day. So next steps, I'm in the pre-sales part of the business, so you can come and talk to me about us running automation workshops on site. Could be security related, could be Windows, networking, you name it, related. Any of these workshops are available to customers that are interested in learning about Ansible and security automation specifically. Or we do discovery sessions where we help people that are already using Ansible and automation to dig deeper into what is the most important to them and helping drive adoption and things like that. So I'd like to thank you very much for listening to me today.